All right, good morning. I feel like it's 8 o'clock in the morning. It's not for me. I hope it's not for you. But if it is, that's great. Welcome to our first online trig class. I am standing in my classroom teaching to nobody. It's kind of crazy. But just know that I am picturing each one of your faces sitting here. Oh, it makes me so happy to see you sitting here in my brain, but you're not really sitting here. Someday you will be, and I'm so excited when that day comes. But until then, we're going to make do with what we have, and I'm so glad I have this board, and I can still talk to you, and you can still see and learn, I hope, the same. So, I'm going to get started. We are starting something brand new. We're starting chapter 7, which is huge in trig. We're going to talk about the law of sines and the law of cosines and all kinds of great things. But let's start small, okay? So far, everything we've done in trig has dealt with right triangles. So we're going to begin chapter 7, okay? Chapter 7 is going to start talking first about oblique triangles. And you're like, Miss Evans, what in the world is oblique? Well, we might have written that definition. You should have written that definition. Actually, I'm pretty sure I just wrote that definition in geometry not that long ago. Oblique just means it's not right. Not that, hey, it's not right, but no, it doesn't have a right triangle. Everything that we have done in trig thus far has dealt with right triangles. Dun, dun, dun. This chapter, we will not talk about right triangles at all. We will only talk about oblique triangles. Now, we'll reference right triangles and what would you do if this was a right triangle, but we will not have any right triangles to deal with. Okay, an oblique triangle is not a right triangle. Okay, that's the first definition that you have to know. Okay, oblique triangles are not right triangles. Okay, we're going to do another little bit of review from geometry. Okay, there were 4 ways to prove triangles congruent. So we're not going to do it. I just want to know, do you remember the 4 ways to prove triangles congruent? If you remember all those symbols, there were 4 ways. Okay, you're thinking maybe you've opened your book to page 302. I'm going to scroll down just a little bit to lose my welcome, but that's okay. You're still always welcome. The first way, or they're not really any specific order, but we have side, angle, side. Okay? If you knew one side of a triangle and 2 sides of a triangle are congruent and the included angle was congruent, then you can prove 2 triangles were congruent by side, angle, side. There was another one. Yeah, angle, side, angle. Okay? Which was, if 2 angles were congruent and the included side was also congruent, you could prove 2 triangles were congruent that way. Yeah, you could do that. Then there was, what other one? Yeah, side, side, side. If 3 sides of one triangle are congruent to 3 sides of another triangle, then yes, you can prove those 2 triangles are congruent. Now in that first green box, that's all. There's only 3, but I'm here to tell you there are 4. They don't list that last one. I guess they don't think it's that important, but it is. The last one, maybe you remember it. Oh, yeah, somebody got it. Or they read ahead. It's angle, angle, side. Okay, that means if 2 angles of a triangle are congruent to 2 angles of another triangle and a non-included side is congruent, then you can prove those 2 triangles are congruent. Okay? Now, this book says, hey, wait, these two are related a lot. You just know two angles and one side. Okay? It doesn't now, in trig, matter the order that they're going to be. Okay? So if you've gone down the data required to solve oblique triangles, they do talk about all four. And the angle, angle, side, and angle, side, angle, they include in the first one, in the first case, together. Okay? One thing you must note, all of these that we did in geometry and that we will do in trig have at least one known side. That is going to be key. You have to have one known side. If you have 3 angles of one triangle and 3 angles of another triangle, can you prove those triangles congruent? Absolutely not. They can be similar, but that's not what we're talking about. We are talking about congruent. Okay? We are talking only about congruency. Okay? We cannot know congruency with just angles. You have to have at least one side. All right, so ultimately, I want to know. We're going to start with the first case. We don't get to the last one for a little while. But if you are given 2 angles and a side, okay, if you're not given a right triangle, Miss Evans, well, how am I supposed to do this? Well, there's something called the law of sines. Okay, I know that you saw this in Algebra 2, so let's just refresh. We don't have to derive it. If you want to go look how they derive it, please, by all means, on page 303. They do a great job of that. I am trying to keep these videos short and sweet. 15 minutes, I'm hoping. I've gone 16, I've gone 18 on other ones, but I'm hoping this one that we'll be able to do short, sweet, okay? If you have the side length, okay, let's go back and refresh how we mark triangles. So if I draw a triangle, that's not a right triangle, okay? Angle A, which will be, all the angles will be big letters, capitals, okay? And across from angle A will be side A. It will be a little a, okay? This you have to keep. This is key to you being able to do anything in this, okay? Across from side B is, across from angle B is side B, little b, okay? Across from side angle C will be side C, little c, okay? So it's very imperative that you remember angle A, big A, is across from side A, okay? Imperative, you have to keep this. I don't know if I can stress it anymore because the law of sines requires that you know this, okay? Because the law of sines simply says side A divided by sine of angle A will equal, these are all going to be ratios, they're going to be proportions. So we can set up proportions for the side divided by the sine of that angle. Okay, so if you have an angle and a side opposite that angle, then you can solve for unknowns. Okay, this is the definition of the law of sines. Now the big question is, could I rearrange these pieces? Sure I could. What if I wanted to write it as sine B over B? It's the same ratio, right? I just flipped it. It's like saying 1 foot is equal to, 3 feet is equal to 1 yard, and 1 yard is equal to 3 feet. It doesn't matter the order I say it because it's still a true statement. Now the issue is the next time I have to put the sine of an angle on top. So my order has to stay the same, but I can flip one flip the other. Could I say sine A over A? Still a true proportion, okay? That is the law of sine, okay? Let's go ahead and work one problem. So I'm most of the time going to draw out my triangles, okay? So if I draw them out, they won't be to scale, so just go ahead and realize that. And then I'm going to go ahead and look at example 1. Okay, sometimes they'll just tell you, solve triangle ABC. Now what does it mean to solve? Solve says, find all missing angles and sides. So if you're given, you have to be given at least 3 things. If angle A, we'll put angle A over here, is 32.0 degrees. Oh, sig figs are coming back into play. Angle B is 81.8 degrees. Okay, so up here is angle C. We don't know angle C, but little a, so the one opposite angle A, is 42.9 centimeters. All of those have 3 sig figs. And it says solve all the missing angles and sides. So we're here solving this. Can we first off figure out what all do we need to know? I need to know angle C. What's the measure of angle C? Oh, I also need side B. And I need side C. Okay, so I'm going to have to solve for 3 things. Okay? Biggest piece is you have to be given an opposite, an angle and a side opposite to use the law of sines. So using the law of sines, we're going to write 42.9 divided by sine of 32.0 degrees. Okay? That will equal, wait, I don't have another side and opposite it, but I do have an angle and a side that I'm solving for. B over sine 81.8 degrees. Maybe I need to put my degrees there because sine can only go with angles, degrees. The side that you're doing, the A and the B, will not have degrees on them, and they should never go with the trig function sine. Okay? So when I cross multiply, right, that's how we solve proportions, correct? So I'm going to say 42.9 times sine 81.8 equals B times sine 32. Okay, how do we solve for B? Out to get B by itself, we're simply going to divide by sine 32. Now, I just need to plug all this in my calculator. Okay, 42.9 sine 81.8. Would you like me to do that also? It's going to take just a second. And we'll solve for B. Maybe you're saying, hey, Miss Evans, actually solving for angle C would have been the easiest thing to do. And you're right. It would have been the easiest thing to do first. Okay? I'm going to see if I can stay here. Okay? So how in the world did you solve for angle C? And then we'll get to the calculator in just a second. So if you know 2 angles of a triangle, can you find the third? Of course you can. So I'm going to go ahead and hit 180 minus 32 minus 81.8, and that should give me angle C. Okay, so angle C equals 66.2 degrees. Okay. Now, to solve for B, scoot this over, I need to use this. Now, you might notice in mine, the last thing that I use this with, I had radians. Using these degree symbols, do you think I should be in radians? No, so make sure you check your mode and change it to degrees. Okay, so I'm simply going to hit 42.9. I'm going to hit sine 81.8. I do the top by itself, I get a number. Okay, so that's the top number, 42.9 times sine 81.8, and we get this 42. But now I still need to divide, so that's going to take that answer, divide by sine 32. I probably didn't need to put that parentheses, but I did. And I get an answer. What is the length of side B? 80.1 what? Units matter, centimeters. Now, wait, does that make sense? Do you also remember in geometry? Smallest angle opposite shortest side. Largest angle opposite longest side. Okay? Well, can we find side C? Yes, we can. We found B, we found A, we only need one more. I am going to have to scroll down just a touch, or maybe I can do it on the side. We're going to try to do it on the side, okay? So, I still have the same ratio, A over sine A. I'm going to use that same ratio over sine 32. This time I want to find side C, so I'm going to put it over sine of the angle we just found, which was 66.2 degrees. Now I'm going to warn you, don't round early, okay? Keep all your decimals. Cross multiplying, 42.9 sine 66.2 equals C times sine 32. I don't have enough room, so I'm going to go ahead and divide by sine 32, and that's going to equal my C. When you plug that into your calculator, guess what you're going to get? That's right, 74.1 centimeters. Okay? We have just solved an oblique triangle. What did we not use? We never used the Pythagorean theorem because we can't. Because the Pythagorean theorem is only with right triangles, does not apply to oblique triangles. I'm just going to give you one problem today for homework, classwork, for you to do on your own. That will be similar to that one. Okay? One problem. Okay, I need you to solve triangle ABC. If A equals 28.8 degrees, C equals 102.6 degrees, and little c equals 25.3 inches. Okay, good luck. I hope to hear from you in our chat. I would like to hear from everybody at some point in time today. But we're going to stop right there because I'm pretty sure I went over. So I apologize. That's why you're only getting one problem. Talk to you later. Bye.